Всем привет. Меня зовут...
Hello there, my name is Konstantin Evteev and I'm working for Avito and I'm dealing with databases. Avito is classified #1 in Russia with the audience all over Russia. It's all about 52 million of advertising. It's about 32 million people with thousands of backends and many other figures, but it didn't. It was very different in the very beginning. You see the tempo of our growth. This is number of views, and as you can imagine, together with this growth, we had some challenges in front of us. How to make data bigger, how to improve our data logics, and we made it because we store everything in Postgres, since Postgres provides you with a lot of tools to work with data and to scale workloads. It's all about amazing community that provides you with best practices, and one of the infrastructure part is standby. And standby is the topic of my today's presentation. Standby solves two problems. First is high availability. If, for example, master goes down, you have to have a standby, and the second objective is about scaling. But now let's have a look at the history of standby. From the very beginning, community said that we don't need replication and it would be a standalone solution, and our colleague Vadim Mikheyev, after MC implementation, based on this, made a rep script, a logical replication, and he said it will be working like this: give me all data that I had in previous snapshot and I will insert it into the next one. Then right ahead log appeared. It's not wall that we have right now. Before that, it was built just to decrease I/O load. Then in 2004, Slowney appeared, and it was a redesigned solution. In 2005, a point-in-time recovery appeared, and a lot of engineers noticed that since we have a point-in-time recovery, if we don't complete this command, we can have warm standby based on scripts. And then warm standby was developing, and in version 8.3 you got a chance to get wall logs, delete those that are unnecessary, and then modification on storage was removed. In 2010, hot standby was made and streaming replication appeared. So now you can use simple protocol to connect to your standby. Synchronous replication appeared in 2011. In 2013, standby can follow timeline switch after crash of master and secondary promoting. In 2014, replication slots appearing as they allow you to implement standby. And however, if, for example, standby crashes, you can use walls, and logical decoding appeared too. Now through API of Postgres you can implement a logical replication. In 2016, multiple synchronous standbys appeared, and remote apply technology was introduced, because when commit happens, then in remote apply you can read the same data from standby. And in 2017, logical replication out of the box appeared. This is the story of our standbys, and we see that standby can be logical or physical. It can be built-in implementation or standalone solution. It can be read-only or not only read-only. It can be sync or async. So now we are going to talk about physical built-in implementation of standby for read-only, and mainly about async.
We are going to do it the following way. So we are connecting an application. It just raises the data from the heap, from the shared buffers, then it does commit while it's written to the operating system cake, then disk archive, Wall sender consumes the wall, then sends to wall receivers, startup processes gets the wall, actually commits them, and conducts the read. How do we scale reads with standby? Part of the users send requests directly to round robin to the master and standby, and in 99% of cases this may be enough. But I believe that most optimal engineering solution is when we have the support, when we have the business requirement, why we can send the request to standby. In Avito, for example, we used to have a requirement that in 30 minutes your advertising will be on website, and that's why if we control that our standby is not lagging behind 30 minutes, we can show all the others, other advertisements from standby. But then at some point of time happens the following thing. When we just wanted to send more requests to standby, we use the Intel processors and hyperthreading. Initially, the load could be easily scaled for hyperthreading cores, but at some point of time, the load profile changed, and the average started increasing. The 28 physical cores CPU time consumption started to increase. That's why we decided to send some of our queries to standby. In this case, so how did we do it? We use the techniques that actually, fights with this tail reads. When we want to read the data from replica, but there are no data on the replica. In order to avoid this, we can do the following. Postgres offers the following mechanism. When you implement the read write to master, at the same time you can get log sequence among number that this record is stored with. Then you can actually put it in cake, object ID and log sequence number. And when you start reading this data, you can actually check in what positions we have the replicas, and if one of them matches, you can actually send the request to this replica. Otherwise, you send the request to master. You can actually see the links below and read in full detail. But if we take the Avito, this was, the monolith story. We had a lot of complex code, and the queries merged 10 different queries, and it was quite difficult to rewrite the application, and we used to work with last updating time that we would indicate with now command, and we started this level, the hot level, to fill with it a time ID and object ID. And it's like an optimization, because if you want to do it in general, it's better to do with LGN. But we decided to use timestamp, and we created a certain border, a certain limit, where we actually put the data into the hot level of cake. On the other hand, we actually were updating the big class after doing the commit of the query. And I'm having nuance. Everything may fall down. We will not write this data into the hot layer. For this purpose, we introduced the second channel. Through notify, we send the signals to master and record it to the same layer. It was important to do because some logics worked with the database, not with the application. And we got the following solution. As the smart cake, we used the Tarantul, quite an interesting memory as DBD, where we actually implemented the hot layer of cake for routing, and the main cake that was moved from Redison. You can actually see at the tract of standby and lag. We got the following layout diagram. We get to level of cakes from the main cake, and if we found everything, it's okay. If not, we're going to the hot level of cake. If we have it there, then they changed it some time ago, and we need to send a request to master. If there are no there and standby lags behind, you need to send the request to query. Otherwise, we go to standby. Here we have the story for time management. I would like to warn all of you, my database doesn't really work better over the time, as transactions can last for a long time. Here we actually had the short transactions, but if you do the long transactions, better do the LSL. The shorter the interval for a standby query, the less we send the request to masters, the more we get queries to standby. But if your standby lags behind, the load will go to the master, and there is no guarantee that it will withstand this load. This is the graph of transaction count for standby, and you can see the drop. These drops can happen due to different reasons, and now we'd like to tell you about the stones we faced in Avito and the way we managed to get away with it. Just imagine you have two tables. In master, on one transaction, you apply operation DDL for the first table and read the second table from standby. On master, you have the DDL for the second table, second table, and in standby you get like the first table. If the version of Postgres is under 10, it's the deadlock. But if it's version 10 or higher, then the structure is actually the same as that activity. You can actually easily see the process. But how did it happen? You can actually edit one table at a time. If we're talking about the DDL, let's just discuss the way we apply or deploy the DDL. We actually set the statement timeout and deadlock timeout. Who uses deadlock timeout? Please raise your hand. Deadlock timeout is an important thing, and I will explain the reason you need it. So, vacuum may prevent the timeout from executing, and just on default, the deadlock timeout is 1 second. And 1 second is the periodicity that traces the vacuum, and if we have the DDL, then it will cancel itself. And 1 second may be too much if you get a few dozen thousands of RPS going to the server. For this, you can set the deadlock timeout and statement timeout together. You need to do it correct, depending on the client, so that it would be applied to your operations. You need to test. There are some nuances. It looks like, okay, you launch it for the first time, for the second time, but at the night time, this DDL operation commits. But on standby, we have this feature. Because these timeouts that we set in master, they actually worked out on the master, were executed on this master. But you cannot set timeout for the standby. It means that all these blocks will come to the standby. So there are some ways to avoid this. You can use several standbys before applying DDA. The standby that is on the load can be paused, play back the changes on a different standby, then switch, reroute the traffic, and then route it back. Another story is like more specific cases. Vacuum and auto vacuum is on for everyone. As you know, auto vacuum may give some space for operating system. There are some solutions that fight with bloat, with update the record, so the vacuum cuts the space at the end of the file and gives it to the operating system. However, when it executes the operations, truncate file end, it takes the exclusive lock, and this lock or unlock happens virtually immediately on master, but on standby it happens together with commit. So in another case, it's like 75 wow, it's way too much. Everything was locked. If you just say in brief, we have a table where we would include a great number of data, then we didn't update it, we did nothing, and then in some period of time we would purge it. Then we got vacuum, and it looked like that a lot of records could be processed. For ourselves, we just changed the table purge periods, but we're gonna face with the problem in the near future. what is the possible solution? You can make an optional parameter that will forbid the execution of some code. We can actually offer it as a community approach, so we can actually prohibit the system to forbid the truncation of files. Then we can actually lower the level of standby vacuum. And then yet another important problem related to archive. In Avito, we have an archive standby through archive, and now I will explain you the reason. At some point of time, the team is generating a lot of files. It's like on the first part of this slide, some got more files generated, but the result was they were accumulated. In the case of link loss, so we would have a lot of data accumulated, but finally we found a way out. We did it as follows. We actually did the parallel sending to archive. The code is in GitHub. You can actually read it. In brief, if we see a lot of files ready to be archived, we actually start archiving them in parallel. The while processing stood at 60 milliseconds. But when we were projecting, designing the file, so we just projecting design. And at some point of view, we started generating some 20 files per second. But when we spend 60 seconds for while, and when you actually check the CPU utilization, you may not catch it, but even in this case, you can actually see that the CPU is heavily used. Our standby we actually send it to archive through the master. Why? Through standby, so we don't have the lag for interface. Then we used other standbys. It just compresses and decompresses. So in reality, the standby was actually compressing and decompressing, and it didn't use the CPU. We needed this just in case if we have an emergency, a fault, so that we would actually be able to take this card. Just in case that master fails, we have a standby and the appropriate archive. That means that we can reconstruct new servers using the archive. But as you know, that new files occupy or take the whole time of any type of feed. It's just, the Pro Archive 2.0. So that was done by my colleague, Gaffarov. So we just if an archive we actually started using the masters, and if you don't fix the archive, all masters will shut down. This task was applied to the CPU. For example, using SSH, we actually compress this archive on the server, and then we send it to two servers at the same time, because archives are written and stored on two different elements. For example, if one storage archive is not accessible, so the system will read the other one. On the one hand, we get the archive backup, and you can actually check the GitHub. You would say, why do we need the archive as we have this streaming? Streaming application shall not compress or decompress files. It's fantastic. Yes, the solution is great, but we need to say that we were designing our system well before we get a great range of the tools. First of all, we need to tell that in 2015, PG receiver slot, and we have a nice reporting here. So, and on this slide we have the references on video, this slide. How can you actually make on streaming standby with archive? In general, we just trying to resolve the problem that the record is done on master, then we get a failure, and standby may in one position, archive may be in a different position, and in order to do the correct disaster recovery plan, you need to synchronize it in a way. And using the PG Rewind, you can easily do it. And actually it works interesting. It makes the rollback by applying the new wall. You need all walls that you're going to go back. If you don't have any, and it may happen, you will not be able to do anything to roll back. So you can say a version 9.6 we got this synchronous replication, and now we would like to tell you about yet another nuance. How does the synchronous replication works? When in master we get the call for backend which says commit transactions, customer doesn't get the commit, then we get the replica, synchronous replica, but we actually stored the data to master. You can even replay it. You can log the playback on standby of this transaction, and then you can reboot the master. Data on master will be written to master, but they will not be on the standby. In general, it works correctly because the client doesn't get the commit confirmation. But if we get a failure when you have these synchronous transactions, then the master falls down. In theory, this archive could get the results, but standby could not get one. And we get to the same problem, that we need to synchronize both with each other. And it's quite interesting when creating interesting knowledge. You need to pose specific requirements in order to know and anticipate what can get in and whether it's appropriate for you or not. If we talk that standbys may lag behind, and sometimes standby under load is reality. You need to operate it and it lags behind. In our case, we can actually make the standby pool. You can do this on the one hand when we are going to send the request to all that all the problems can go to all the standbys, and that's why all of them will lag behind. That was the reason we decided to go a different route. We actually send a load to one standby until it lags to the maximum threshold level. We do not open it up. And when it lags behind reaching this threshold, we just open it up and waiting for it to recover the standby. In order to implement the logics, you need to store somewhere that we are on standby and that we have reached this level, this limit. You can actually make the Perl language and write it to a file, or you can actually use the foreign data wrapper and you can easily write this information to standby.
Now a couple of words about monitoring, and also I wanted to tell you about key metrics while monitoring standby. First off, it's CPU monitoring. It is important when it comes to archives, but when we are going to talk about pools, I will get back to this once again. You have to monitor the amount of dirty data while it comes to RAID controller operations. For example, we have RAID controller configured to 100% to write operations, and if the amount of dirty data is more than RAID controller cache size, we will work with the disk, and now it's other latencies. And in this case, you can find yourself in a very tricky situation. Wall traffic. The amount of traffic is crucial for your archive command performance. for your network controller utilization, and at the same time it is at least interesting just to know how much data you are writing. TPS per transactions per second, very trivial graph, but this is the first thing I'm looking at because I can diagnose the number of problems by using this, and I will tell you why why it looks like this. PGStat statements is a very interesting tool, which is like a universal, like a Swiss multi-tool. You see that we are monitoring total time of all queries on server and compare it to the same data from the previous week, and you can see the number of queries, the length of queries, of templates, the number of writes and other things too. So I am recommending to use this tool while troubleshooting. Now we have some overhead for connections. We have caching layers. That is why we are using pools. It can be application pool or PgBouncer or other poolers. It is very important to monitor this to avoid queues. For all our customers, for all our production teams, we say if you have waitings, it's a big problem, nothing works. At the same time, you have to monitor connections per pool. Also, you can keep an eye open on metrics, on requests handled by your pool. These metrics are crucial to understand the size of the pool, and here comes a very interesting story why it is so important to pick up the right pool size. We have schemas for codes in certain projects where when we change some procedures, some stored procedures, we deploy a new schema with a new user. And it happens, and also we use the following techniques. We would like to test a release. So we will have old users and new users from the old app. And PgBouncer has this particular thing. If you miss the pool size, because they have limitations on pool size, on user connections, if you miss the limitations with canary deploy, these two users will be fighting for the same pool. And in this case, we have bouncer eviction, so connections are being pushed off, and you get rid of all the benefits of PGBouncer. In this case, you have CPU spike because you have replanning and other big problems in production environment. So this is one problem. Also, I wanted to tell you about problems with TPS. You can't afford code waitings. It's when we have anti-paddling, when a base is used by several clients. So this is a problem with the bouncer. As I told you about archive and NFS, it will be worth saying that you have to monitor this too, because sometimes you can accidentally launch ls and all your servers using this client will be working very slowly. So archive command will stop working almost, or you will launch some utility that will load NFS. So you have to keep an eye open on your NFS or your archive. So conclusions. At the end, I would like to tell you that there are a few kinds of standbys. I was talking about binary standbys, but We were talking about logical standby several times too, and including logical replication. You can use it too. We were talking about how to scale reads with the help of standby. We take a look at different problems with standbys in production. We take a look at the importance of disaster recovery plan while building archive and backups. Because if something blows up, it's very difficult to deal with it in 4 a.m. That's why your archive and your standby have to have a very strict disaster recovery plan. It must be tested, it must be streamlined, and you have to know what happens in case of failure. Also, we need to say that if you have standby OI, it means that one master will not be enough for all your load, so you have to have some redundancy, and also you need to know how to update. My major upgrade with standby also needs advanced manipulations. You have to have standby. So on one hand, there are logical replication tools built in. You can use downtime, zero downtime, and also with minimum downtime you may use PG upgrade and rsync, and that's what we are using. But some tricky things can happen. I would like to pay your attention to the fact that if you have standby through archive and you make upgrade to master and to standby, in documentation it goes that for streaming replication, if you are using archive, when you switch off standby, the last wall from master will not go to archive and will not be applied to master, and you have to do it manually. Otherwise, when you sync your standby to your master, you will apply it to a different state and you will crash your cluster. Secondly, just from Avito, we reported it just yesterday, and you can read about this by using this link. So while using standby, we are using the following technique. We have a hypothesis. So reads on standby go to changing data, and these reads interfere with the replication. And to avoid if a vacuum happens, these dirty data are cleaned up and it interferes with your replication. So in transactions, you can actually set how much time vacuum will not do anything with this dirty data. And in documentation, we didn't find a single page that we can't use this parameter. And when we started to use this technique after PG upgrade, we set it the transaction counter. It wrote I can't launch cluster because I don't see a database, let's say HH, and it refers to this setting. If we put transaction counter forward, or everything will be okay, and you can make a report and you can also add a patch, and it was not obvious for us. Therefore, cleanup page. So that's it from my side. I'm hoping that my presentation would be useful for you while using standbys. And also, I would like to say that in Avito we have a lot of interesting tasks, and you can apply to our company by following this link. And now I'm ready to answer your questions. Hello. Tell me, please. So you have standby configured for archives. In some places we use streaming, but for most cases we use it for archive. When master crashes, we would like to restore standby in any case. What's the delay between master and standby? It's clear that they are not synchronized. It's about milliseconds. Really? So it comes that streaming replication can be replaced with archives. Yes, and that's a very decent question, and I forgot to tell about this. Streaming replication is faster, but archives can catch up with streaming replication, because replication and reading traffic in fact can interfere with replication. If we compare these two things, streaming replication is when we are running a long distance, and archive is about short sprints. So when we're talking about standby exploitation, through streaming it works better because it plays these changes step by step. So the interval is very short, but still it's step by step. Sometimes we use standbys in production. For streaming we have archive, but in case of a failure, this streaming standby will be in future. We can use rewind to get back. If we comply with this requirement, we can use PG rewinder back to archive state, or just discard it, use other standbys. So we have different schemas, but in most cases we just discard it. And my second question is, what happens to master? What do you use to fail over to standby? We have our own implementation, and maybe we will tell you about this one day, but now we are use Petronia. We have our own development, our native development, and we didn't open source it. It works like Petroning. So the feature list is almost the same. Petroni is more developed and more interesting, and then we just understood how to work with this. For our own failover solution, we have a synchronous Postgres. Thank you. The question from the first row. Do you turn off host standby feedback? Yes, when we use streaming. Any drawbacks, any side effects from this? We didn't encounter them, in fact. For streaming, we have standbys that are used for synchronous replication. But in most cases, we use standby for archive. Do you use default cleanup page when it's switched off? I have to clarify this configuration because we set these parameters step by step. We need to have a look at the history. Standby feedback, in what version was it? We used this cleanup page in version 2, so I don't remember exactly. It was maybe version 9.5, just different versions. In production we have versions 9.4, 9.5, 9.6, version 10. We are testing version 10 very intensively. So as far as your question is concerned, we just need to take a look at the configuration and don't remember it exactly. Thank you for your talk. Tell me please, did you manage to play DC from Yandex for poolers? because you said that we can use PgBouncer pooler or any other pools, but we don't have many poolers. Odyssey is a very decent pooler, but we didn't try it because we are using PgBouncer. I saw its feature list. It's a very decent solution, but as far as our company is concerned, we have already settled all other questions with PgBouncer. In fact, our production team decides on their own how to work with the database, and production team can use not only PgBouncer, but for some reasons they can use application pooler like or Java or any other built-in poolers. Okay, got it, thank you. Hello, and thank you for your presentation. I would like to ask a question not only about standby, but about one slide in yellow load. I saw that TPS counter with the jump is around 7,000 and you have around 100 active connections, which is pretty amazing. Is it metrics from master or is just a summary? It was a metrics from standby. And for this standby we have around 7,000 transactions per second, but the number of connections, I'm not sure that is 100 active connections. For example, for masters, we have a lot of masters. I don't remember what about standby, but with regards to masters, services are very loaded. We have some heavy transactions like 8, 9, 12,000 transactions per second, and we have around up to 50 active connections, maybe 30 active connections per physical course. Are you using reindex cluster for masters? Do you have any experience? We just wrote a script for it, and we also have some tool that is looking for indexes. So these are very short operations, not like 60 or 90 minutes. For concurrently index or reindex can run for a couple of hours. But do you have any problems with this, with replicas? If we don't have long transactions, there are no problems with the index and with replicas. What problems are we supposed to encounter? Like when you abort the operation, you roll back. It's just about the amount of walls. It's just about the number of walls that your server can process. I think we have run out of time. Okay, we can ask a couple of questions more.
Could you please tell about in more detail how do we calculate the pool size? Well, pool size, how do we choose it? If we go from the scratch, you take the envelope of your system, think about the requirements, what the requirements are, what the requests, the data type, what type of queries we're going to execute. Then you do the load test. And based on this, you can choose the hardware configuration and build up architecture and select the pool size. What I was telling you about is actually doing the hard run to check whether we have the right or correct the pool size. Check the metrics, how many queries per second you get, the average length, and how many connections or joins do you get in order to select the correct pool size. But do you have a rough formula how you can actually calculate, or is it the only way by empiricism? When I was telling you the story, when we actually do the deploy, And when we had this canary deploy, when we started to calculate the pools, I had to calculate the number of the pools to select. For this, I actually checked the number of pools, how many SV active bouncer. I just checked that. For one user, we get some, 12 active connections. Then I just check the number of queries per second processed, but we have also additional metrics that actually shows the average query processing time. For example, I matched everything together, all these figures match. I see like 12 connects are enough, and I just decided to make 20 just to be on the safe side. Thank you. Okay, now we would like to invite the next presenter. Thank you, Konstantin.